Hello, I welcome you all to this another interesting screencast. The problem reads, determine the coordinate direction or direction angles alpha, beta, and gamma of f for which is applied to the end A of the pipe assembly so that the moment of f about O is 0. The second problem is determine the moment of the force F about point O. The force is coordinate direction angles of alpha equal to 60 degrees, beta equal to 120, and gamma equal to 45. Express the result as a Cartesian vector. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Alright, so the first case, we have been asked to determine the directional angles, alpha, beta, and gamma of the force F, so that the moment about point O is equal to 0. Alright. So what do you think we are supposed to do here? Okay, let's draw the momentum from O to this point that we are going to call B. Let's call this point B. So before I continue solving, let me make mention of this. We can solve this problem by either using the scalar or the vector approach or approaches, okay, or a combination of both. Right. For me, I'm going to use the vector method. So what do you think we are supposed to do in the first case so that we have the moment about point O equal to 0? About O equal to 0. Alright, let's look at this. Let me just show the angle between these two vectors, the first vector and the moment arm. Let's call this moment arm as RB. So what do you think the angle between the two vectors is supposed to be equal to for us to have a 0 moment about point O? What do you think? You know this formula, right? If you have two vectors like so, okay. For you to have, let's say this is our point O there. Then we have moment. This is R, this is the force. So moment is equal to F, okay, times R sine theta. Alright, R is the moment arm. What do you think theta is supposed to be equal to for you to have a 0 moment about point O? Of course, for you to have moment equal to 0 at point O, you expect theta to be equal to what? 0 degrees, okay, or 180 degrees. Of course, in the range 0 to 180, if our angle is from 0 to 180. So when theta is equal to 0, you'll have a 0 moment because the moment arm is going to be equal to 0, okay? The moment arm will be equal to 0 because you expect these two to be what? To be perpendicular, right? For you to have a moment about point O. So if theta is equal to 0, the moment arm is going to be equal to 0. When theta is equal to 180, you expect the moment arm to be equal to 0. So it's the same thing also here. Alright? The angle between these two vectors, the moment arm and the force vector, when the angle is 0, or when the force vector and the moment arm, the moment vector arm are collinear, okay, and they can only be collinear when theta is equal to 0 or theta is equal to 180, right? So the moment the vector force and the moment vector arm are collinear, then it means you expect moment to be equal to 0 at point O. So by collinear we say the moment arm and the force vector are parallel, they're in the same line, okay? Or so you can have this one case, or you can have the moment arm and the force vector like so. So both these two cases will produce 0 moment about point O. The force vector and the moment arm in the same direction but collinear. The force vector and the moment arm and the force vector are collinear but in the opposite direction, they will still produce a what? A 0 moment. So we are going to tackle two of these very quickly. Alright. So what we need to do now is, for these to be collinear, this force has to have the same direction, the same coordinate direction for the moment arm. Alright. Alright. Great. Is that fine? Great. So I'll need to write down that. So let's start. So case 4-18 like so. So we are saying moment about point O is going to be equal to 0 when RB and the force vector are collinear. Okay. And this will take place when theta is equal to what? 0 or 180. So we're going to have two cases. So now the direction angles for the moment arm should be equal to the direction angles for the force vector, for them to be what? Collinear. So we'll just concentrate on finding the direction angles for the moment arm. So let's write down the vector expression for the moment arm. So this is going to be equal to, in the x-axis we have a 6i, in the y-axis we have a 14j, and in the z-axis we have a 10k. And the magnitude of that is just going to be equal to what is it? Just a 6 squared, 14 squared plus 10 squared. So right, so we have 18.22. 6 squared plus 14 squared plus 10 squared. Okay, 18.22. So now let's find the unit vector that will allow us to find the direction angles. There we go. So this is just going to be equal to 6i divided by 18.22 plus 14j divided by 18.22 plus 10k divided by 18.22. Therefore, so now the first case is where the force vector, the moment arm, is all facing in the same direction. This is the first case. And for that case, you expect cos alpha to be equal to 6 over 18.22, and therefore alpha is just going to be equal to, and alpha is the angle between the positive x-axis and the force vector. So 6 divided by 18.22 18.22, and then cos that gives us a 70.77. And then we have cos beta. This is positive y-axis, and the force vector. So 14 divided by 18.22 cos inverse is 39.79 degrees. Okay, and then cos gamma, which is just a 10 divided by 18.22. Gamma is just going to be equal to 10 divided by 18.22. This gives us a 56.71. So 10 divided by 18.22, 56.71. 14 divided by 18.22, 39.79, and 6 divided by 18.22, 70.77. Great. So this is the first case. The second case is where we have the force vector, I mean the moment arm and force vector are collinear, but they are collinear but in the opposite direction. Okay. For a case like this one, we are just going to subtract. We're just subtracting 180 from this, or just change the sign for the unit vector. Okay. So if you are to change the sign, you realize that 180 minus 70.77 will get a 109.23. Okay, 109.23. Okay, this is what we intend to get. Or if we don't want that, I'll show you. We just need to change, instead of having a unit vector like this, the unit vector will be PO, okay, which is just going to be equal to negative 6i divided by 18.22 minus 14j 18.22 minus 10k 18.22. Okay, and then alpha here will just be equal to minus 6 divided by 18.22, and then cos that we just get a 109, like I said, 109.23. So we do the same for beta also. You just subtracting 180 minus 39.79, which is just also a minus 14 divided by 18.22. Cos inverse of that, minus 14 divided by 18.22, and cos inverse of that, we just get that difference to 1, like so, degrees. And the same applies for negative 10 divided by 18.22. The same also applies there. We have gamma equal to 123, which is just the difference from 180. Okay, so these are the two cases that will give us a zero moment. Okay, case A or case B, and we found the angles. Right, let's go to the second case. Case 169. Case 4-169. So this one, they're asking us to find the moment about point O. Let me wrap this. Okay. Alright, they're asking us to find the moment about point O. So let's find this moment. Let's find the force. We find the moment about point O given the angles. So this force, right, we can write it here. So we have this force, the force vector is going to be equal to 20 cos 60 degrees plus, sorry, I'm supposed to indicate an I there for the direction, plus 20 cos 120 j plus 20 cos 45 degrees k. This is just going to be equal to a cos 60 is 0.5, right? So the first one is a 10 I. A cos 120 is negative 0.5, right? So this one is a minus 10 j, and then we have 20 cos 45. This is a 14.1421 k. Alright, we already have the moment arm, we already found it, but I can write it here again. It's just a 6i plus a 14j plus a 10k. So using vector expression, we have RB cross F, which is going to be equal to, let's plug it in our user-friendly tool, IJK. So we have a 6, we have a 14, we have a 10. And then at the bottom here, we have a 10, we have a minus 10, then we have a 14.1421. Okay, that's 20 cos 45, 14.1421. So let's work out this. So we have I, what do we have? So we have 14.1421 times 14, okay, minus becomes a plus 100. So this becomes a 297.99 minus j, okay, 14 by 14.1421 minus 10 by 10, 299.98, which is 99, 297. So for j, say 14.1421 by 6 minus 100. So this gives us a minus 15.15, and then plus k. Okay, we have a minus 10 by 6 minus 10 by 14. This gives us a minus 200. Therefore, our moment about point O is just going to be equal to 297.99 I plus 15.15 j minus 200 k. Okay, this one is pounds inches. So we have expressed the result in Cartesian form. Let's find also the magnitude, maybe. What is the magnitude? 297.99, 297.99, 297.99 squared plus 15.15 squared plus 200 squared. This is equal to 395.20 pounds inches. So 297.99 squared, 15.15 squared plus 200 squared, square root of that, 359.20. Great. So I think we are done, right? Let's just outline our solution. So we have two solutions here for the first case. The values of alpha when the force vector and the moment arm are in the same direction. Of course, you expect them on first condition to be collinear, but they can be collinear in the same direction and collinear as well as in the opposite direction. So we found two cases. Both of them will give moment equal to 0 at point O. Okay, there, and that one there. All right, and then we found the moment. Expressed as a vector about point O, and we found the magnitude as well. So you cannot talk about a vector without also computing its magnitude. Right. Great. I think this is about it. And I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.